If at the end of the second module of SAT Math, every time you click next, you find yourself hoping and praying you're not going to run into one of those awful geometry questions next, this is going to be an incredibly helpful video for you. We're going to take a look at 5 different question types that have all shown up on the real SAT at least 2 times and will likely show up on the test again. And we're going to show you how these questions that you may initially be dreading are actually quite easy to solve once you understand the proper strategies and steps. And whether you see these exact question types again or something related, we're going to arm you with the proper strategies for being able to solve them. Now, the first question type that always stumps students is these pyramid questions. This is really tricky because the SAT is mean and they have not put any of these on their Blue Book tests. So when students encounter these on the real SAT, they have no exposure to them and they're not sure what the strategy should be. Now, they're also tricky because they don't come with a visual, but luckily in the reference sheet, we do get this visual, so always look at this. But the simple tip, which is going to be super helpful for you, is these pyramid questions are Pythagorean theorem questions. And an easy way of remembering this is a fun fact is Pythagorean theorem was used in the construction of the pyramids, so that sometimes helps students remember this. But you can create Pythagorean theorem 2 ways with these pyramid questions. You can create a right triangle here, but more commonly we will create a right triangle there. And what I'm going to shade in green is also called the slant height, and a lot of students forget what that term is. So since it's a Pythagorean theorem question and we're trying to solve for the height, we need to solve for that blue shaded region and that green shaded region, and then we can do a squared plus b squared equals c squared. Now here we know the total surface area, so that's going to be of our square base and the 4 equilateral triangles, not equilateral, the 4 equal triangles of those lateral faces. So the first thing we can do is we can solve for the base. We can do that by doing 109,440 minus 73,340. That will give us 36,100. Well, since the length and width have to be equal here, we can just say those are both x. Let's say x squared equals 36,100, and that will give us that x is equal to 190. So we now know that all of those pieces here are going to be equal to 190. And this also lets us solve for our blue shaded part. That's going to be half of that length, so it's going to be 95. Well, now we know all of those 4 lateral faces are equal. So if we take our 73,340 and we divide it by 4, that's going to give the area of each of those triangular faces, because these are just going to be triangles. And we know the base, so we can solve for the height, which is going to be the slant height of our pyramid. So we now can divide it by 4. That will give us 18,335. And that's going to be equal to 1/2 of our base, which is 190. And then we'll just qualify this as y. That's going to be our slant height. Now that will give us that y is equal to 193. And now we're all set. We can simply do our h squared plus our 95 squared is equal to the 193 here squared, and then we simply have to solve through, and that will give us our correct answer of h equals 168. Just remember, if you see pyramids, think Pythagorean theorem, and you're going to be able to solve these. Now next up are similar shapes, and you may look at this and be like, oh, this also looks like those inscribed shape questions that I hate. We're going to talk about particular tips around those later in the video, but they can occasionally be similar shape questions like we're seeing here. So here we see BC is the diameter of the circle. The length of BC is equal to 132. The length of AB is equal to the square root of 363. What is the value of BC over BD? Now, the first thing we want to recognize, and I kind of gave this away a little bit, is these are going to be similar shapes. We know this is also going to be 90 degrees. We know this measure will also be 90 degrees because BC is the diameter of the circle. This is kind of using inscribed angle theorem to get that that is 90 degrees. Now, what students really struggle with here is they start to struggle to visualize how they're supposed to set up the proportions. So a tip that I often recommend to students that makes these questions a lot easier is to insert angle measures so you can start filling them out and you can identify how stuff is similar. The ones I recommend to use are simply 40 and 50, so you don't think it's one of those special right triangles. So all we're doing is we're inserting these to make it easier to track. We do not actually know what the angle measures are. So we of course know this is 90 degrees, and so we're going to start with our big triangle of ACB. So we will simply say this is 50, and therefore this would be 40, because all of those angle measures in that big triangle have to add up to 90. Well, if this is 40 and this is 90, that means this angle measure here has to be 50 and this angle measure has to be 40. Now it's way easier for us to identify what side lengths are going to be proportional, because anything opposite the same angle measure is going to be in proportion to the other ones. So the next step is going to be to draw all of the triangles out with those 40, 50, 90 in the right positions. Now, once we have these drawn out, it's way easier to set up our proportions. Now we're going to see that we're going to only be using these two triangles because we don't have any information from this one. But remember, we are trying to solve for BD, so we'll put X here. But now we can see that we can set up the proportion as 132 is to root 363, root 363 is to X, and that's going to let us solve for BD, and we're ultimately trying to find BC over BD. So we're simply going to set that up. We will do the 132, our first hypotenuse, over our second one, over root 363, and then we will set that equal to, we're doing bigger to smaller, root 363 is to X. Now we can just cross multiply. We'll get 132x is equal to 363. So that's going to give us that x is equal to 363 over 132. And so that's the value of BD. So if we're doing BC over BD, we are simply going to be doing the 132 over 363 over 132. There's our BC over BD, and this ultimately is going to be equal to 48, and we can find our correct answer. So we're gonna have a brief intermission. I know if you're watching this video, this means you're really trying to succeed on your next SAT. And if you wanna improve your score by 100 plus points guaranteed, I strongly recommend checking out my Ultimate SAT course. We have helped students get perfect scores. Tons of students score in the 99th percentile, and many students make absolutely incredible improvements. You can check it out on our website, and you can also check out a free trial. No credit cards are needed as well there. Now, the next thing that feels really overwhelming for a lot of students are variable heavy shape questions. Now, if you do see these are probably actually the most straightforward of the varieties that you can see. You really just have to lean on your formulas and be very careful with all of your steps. So here, a right rectangular prism has a base area of 55 z square inches. The length of the base of the rectangular prism is 15 inches, and the height of the rectangular prism is 7 inches. Which expression represents the surface area in square inches of the right rectangular prism? Well, two things we always want to do initially. Make sure we know our formula and draw the figure out so it's easier to visualize. Now, since we've drawn this out, what we can kind of recognize is we know the length, we know the height. All we need to use our formula here is we need to know the width. So to determine the width, we know that the base is going to be equal to length times width. So we can solve for W by doing 15W is equal to 55Z. So therefore W is equal to 55 over 15Z, which we could simplify down to W is equal to 11 over 3Z. Now we know all the pieces, we simply have to plug them into the surface area formula. Now, we already know that the length times the width is going to be 55z, so we can go ahead and we can do our surface area is 2 times the 55z, or you could plug in the length and width there, plus 2LH. We know the length is 15, so 2 times 15 times 7. And then plus 2WH, so 2 times, we know our W is 11 over 3 times Z. I'm going to move this 15 out of the way just so I don't run out of space here, and then times the height times 7. And so that will end up giving us C is our correct answer. Now, next up is inscribed shape questions, and students constantly are complaining and feeling like they're struggling with these. Now, we looked at one a little bit earlier, and so some of them can be similar shape questions, but 9 times out of 10 when you see these inscribed shape questions on the SAT, they are secretly special right triangle questions. So with that in mind, see if you can pause the video and work through. Now, with the question here, we see a circle is inscribed in a square such that the circumference of the circle touches the midpoint of each side of the square. The length of the diagonal of the square is 256 units. What is the area in square units of the circle? Now, first thing we want to do is draw this out. So now since we have this drawn out and we have that diagonal of the square drawn in, what we really just want to think about is we're trying to solve for the area of the circle. So what we want to determine is if we can determine a side length of a square, that's going to give us the diameter of the circle because that's going to go all the way from the top to the bottom. And so once we know that, we can take half of that and that's going to give us the radius. And we know our area for a circle is pi r squared. So with this question here, when you see anytime you have a circle inscribed in a square, we're dealing with 45, 45, 90 triangles. All of the angle measures of the square are going to be 90. So when we have this diagonal, we cut it in half. We're going to now have created 45, 45, 90 triangles. And so we now can just think about those proportions we get. That's going to be x root 2 is the hypotenuse, and the side lengths of the square are going to be x. So I'll put these outside just so it doesn't look like we're labeling the circle as x. So those are x. Now we just need to solve for x. We'll take half of it and then we'll square it, and that's going to help us solve through. So we simply are going to say 256 is equal to x root 2. So we're going to divide both sides by root 2. That will give us that x is equal to 256 over root 2. And therefore, x is equal to 128 root 2. Now we want to remember, we were looking for the radius here is going to be half of x. So that's going to be 64 root 2 is equal to the radius here. And so therefore, we know the area is pi r squared. So the area is equal to pi and then 64 root 2 squared. And that will end up giving us B as our correct answer. All right, the final concept we're going to talk about has shown up a ton as one of the last 1 or 2 questions on the second harder math module, and this is scale factor questions. Now, these questions feel really difficult because students feel like they don't have enough information to possibly solve them, but I've kind of added on the screen here our scale factor rules from our math book, and if you memorize these and understand these questions become way easier than they look. So, scale factors are the multiples between side lengths in similar shapes. So we're going to go through the rules and we're going to come back and apply it here. So we're just going to use 2. If the side lengths are 2 times bigger, the perimeter of one shape compared to the other, the larger one is also going to be 2 times bigger. Now, this is where it becomes really important and where students often struggle and miss these. Area and surface area, the easy way of remembering that your multiple between the area and the surface area of the smaller and larger shapes are going to be your scale factor squared is because those units are in squared units. Area, surface area, squared units. So you have to square your scale factor. So if the scale factor is 2, our area and surface area multiple are going to be 4. Volume is in cubed units. So you have to cube your scale factor. Now what these really complex questions make you do is work from something like area multiple back to scale factor to be able to move to volume multiple. If we can kind of use these rules and work in those directions, we can solve these really complex questions quite quickly. So see if you can pause the video with that information in mind and solve through. So here we see right rectangular prism is similar to right rectangular prism B. This tells us we're probably dealing with scale factors. The surface area of right rectangular prism A is 84 square inches, and the surface area of right rectangular prism B is 5,376 square inches. The volume of A is 18 cubic inches. What is the volume in cubic inches of B? Well, what we simply want to know here is if we do 5,376 divided by 84, this is going to give us our surface area multiple. So if we punch that into our calculator, this is going to be equal to 64, and what we want to remember is our surface area multiple is our scale factor squared. So we always want to try to work back to the scale factor. So to work back to the scale factor, we have to take the square root of that using those rules. So that means our scale factor is going to be equal to 8. Well now, if we're looking for our volume multiples, we are going to have to cube the scale factor. So we can find our final answer by simply doing 18 times that 8 cubed, and that will give us our correct answer of 9,216. With these, if you memorize these rules that I've popped in from our book, you should be able to solve these pretty easily. Now, if you guys have any questions on anything from the video, please drop them in the comments. If you are looking for more really difficult geometry questions or practice with the other types of really difficult questions you can see at the end of the second harder module, I strongly recommend checking out our advanced math courses. They've delivered amazing results for students, and all of the questions in this video were featured in those advanced math courses. They're representative of the types of questions that have been showing up on the real SAT. So it gets you used to those varieties, gets you used to the skill sets, and hopefully, as you are seeing here, these questions are not nearly as awful as they look. You just need to understand the proper way of solving them.